So now we are discussing a few equations from physics. So first, Maxwell. So Maxwell is a big name in physics, and it's related with the equation for electromagnetism. So it's very, very important because everybody uses electromagnetic fields, like your phone, so it's very important. And so I recall that if you have a function phi, so what I'm talking about comes from the book of Rabbi, okay? Uh, and so I will mention also the reference. But so I recall that the gradient I used a couple of times, but since we are going to write these equations, gradient of phi, so phi, let's say phi now is a function from R3 to R, but it's in L2s. And so this is d phi dx1, so d phi dx2, d phi dx3. Okay? All right. Now you have the divergence. So now if you have F, so capital F, which is F1, F2, F3, this belongs to L2 of R3 to the power 3, because you have three components, okay? And so in this case, the divergence of capital F is, so you write it like gradient scalar F, because it's df1 dx1 plus df2 dx2 plus df3 dx3, right? And finally, you have the curl, and you write it like that. You write it like that because it's analogous to the product of two vectors, and it's so df3 dx2 minus dx3 f2. So it has three components. Then it's minus df3 dx1 plus dx3 f1. And finally, it's df2 dx1 minus df1 dx2. Okay? So now, what are the Maxwell equations? Maxwell equations. They give the time evolution of vector fields. Okay, so they are applications from R3 into R3. So it says that the time derivative of the electrical field is minus some constant C curl of H. And the same thing for the magnetic field, but it's C and curl of E. Okay, then you have the divergence of E is 0, and divergence of H is 0, and you have initial conditions. So initial conditions are given. So what you are considering as operator A, it's this one. Okay, so you will say A E H is minus C curl of H and C curl of E. And so the operator goes. The operator goes it's GA in let's call it H, and H is what? H is in fact L2 of R3 6, and GA will be uh, well, you need this thing to belong to H. So GA such that minus C H and C E belong to H. Okay, so in this setting, you can prove that. So this is in Vrabi. So A generates a C0 semigroup. All right. Okay, now we can just discuss also the Schrodinger equation. So the Schrodinger equation gives you so this is ut equals I I Laplacian u minus v x u. Let's say that u equals 0 on the boundary. And you have also an initial condition, of course. So one thing that works is to took so you will choose d of a equals u in h10 of omega, but of course you allows values in c, and you have that the Laplacian of u belongs to L2, and a u equals I Laplacian u. Okay, so theorem A generates C0 semigroup. So that means that it gives you the solution of my Schrodinger equation. Lastly, this is the last thing that we are going to mention, is the classical uh, wave equation. So we already did it in 1D. All right. So now it's UTT equals Laplacian U equals 0, U0x equals U0x, and UT0x equals some other function, let's say V0 of x. So you can write it classically UT equals V, and then VT equals Laplacian U. And so the initial conditions become U0x. Oh, I forgot. So you have U equals 0 on the boundary. And now it's V0x equals V0. So if you will choose the operator AUV to be the Laplacian U. And so if you if you consider D of A so let's H be so you choose U2 belong to H10 and V to be L2, and then D of A equals uh, the UV that belongs to H, such that you need that V belongs to L2, that's okay, and Laplacian U belongs also. So it's V belongs to H0 and U belongs to and Laplacian U belongs to L2. Then theorem A generates C 0. Okay, so just a few things. So what's a very short summary? Semigroups generalize. The concept of solution of u prime equals AU when A is a matrix in Rn to the case where A is an operator in a Banach space. Right, so this allows to clarify and provides a framework for equations such as, so this is the heat equation, wave equation, and etc. etc. So we saw today Maxwell, we saw Schrodinger. Okay. Then, but you have some questions of estimates of, you need sometimes bonds, compacity, and other things. So one other thing to include is, which is powerful, is the theory of analytical semigroups. Which gives you more insights. So about regularity, bounds, and so a typical equation is ut equals AU. So there are several references for that. I will give you the one in Vrabi, but I will mention also other references.